All right, so today we're going to keep talking about pyramids. We're going to hit some area and volume today. But before we get there, I want to look at a problem that's similar to what we did yesterday, but it's giving us some different information. It says we've got a square pyramid here, and all the base edges are 10, and the lateral edges are 13. So they didn't give us lateral edges in a problem yesterday, so it's a little bit different. I know each base is 10, which is nice because that means this side over here on the right, each of those little pieces is 5. Might help us out in a minute. I also know that the lateral edges are 13, so that's not the slant height. This is like where the sides, the walls are meeting each other, so we didn't have one quite like that. What we're going to have to do is find the height. So this line right here is what we're looking for. But we're going to have to find a few things to actually make that work. So let's draw our slice triangle, the one with the H. I'm going to draw it down here. We're looking for this piece right here, the height. It's a horrible H, sorry. So now I know a few things about it because if I draw the square base, which I'm just going to sketch it real quick, I know I have the apothem in there, and that's the same as the base of that triangle. This is the apothem right here. Okay, that's what we're about to find. Well, this is a 45, 45, 90 because it's in a square. So this piece is 5, which is an X. Well, this is an X also, so that means that is 5. So what I know is that the base of this triangle is 5. So if I can find the lateral height, which is the hypotenuse there, then I can actually finish off my problem. So let's go ahead and draw one of the lateral faces. It's just a triangle, looks like this. So this is like one of the walls of the pyramid. I know that the base of this is 10 units long. And I know that the sides of it are 13. Remember, this 13 is like where the walls are connecting. The 10 is where it's sitting with the floor. But because I need to find the height, that's what will give us our L. That is actually the slant height. I know because that hits the middle that this piece is 5. And now I have a right triangle that I can use with Pythagorean theorem. So I know L squared plus 5 squared is going to equal 13 squared. And when you work that out, you'll end up with L equaling 12. So I now know that this side is 12, and I can do Pythagorean theorem again. So I need my H squared plus my 5 squared to equal 12 squared. That gives me that H squared is going to end up equaling 119. So we take the square root of both sides, and we get H equals the square root of 119. If you want to give that to me as a decimal, that's fine. So that's basically just another way to look at this. We can look at, I think there's a couple on the homework, and we can look at that tomorrow if you're having any trouble, because we definitely have to do a little bit more work there. Now, all these definition guys are talking about using the net to find things. And like we did with the prisms, I think not using the net is easier if I just straight up show you the equation. So I'm going to go ahead and give you the equations for finding lateral area. That's just the sum of the areas of the faces. It's going to be 1/2 big P, perimeter of the base, times L, the slant height. So remember, big P, perimeter of base. So sometimes that's easy to find, sometimes it's not. If we're going to find the total area, so this is all the walls plus the floor, it's still 1/2 big P times L, but now we're going to add in the area of the base, okay? And I think y'all remember that, big B, area of the base. And then we have our last one, the volume. We already know it encloses in a 3D object. It's actually right here, okay? So volume is 1/3 big B times H. Now remember that H is the height of the pyramid, okay? So I'm going to go up here to this one. Remember the H in this one was from that vertex to the center of the base. So remember, don't get that mixed up with a height of a triangle or the slant height, okay? So we're going to look at 2 of these. They're not that bad. Go ahead and get started. Now, of course, if you wanted to use the net to do this, you could find the area of one of the triangles and multiply it by 4, but I think we're better off by using our equations. The things that we need to find, we're going to have to find the perimeter of the base every time. We're going to have to find the slant height. We're going to have to find the actual height of the pyramid and the area of the base. Now, today it's going to be pretty easy, but tomorrow it's going to be a little bit rougher, so really pay attention today. The perimeter of the base. Well, I know the perimeter is a square base. Each side is 10. 10 times 4 give me the perimeter of the base as 40. It says I also need the lateral height. Well, it actually gave it to me right here. This line coming down the middle of one of the walls is the lateral height, 13. What it didn't give me was the height, and I'm going to have to do a little bit of work for the base. So the base, or the area of the base, I'm sorry. The area of the base in this one is length times width, 10 times 10 gives us 100. But to find the height, we're going to have to use our slice. Okay, so it's vertical there to a right triangle. I'm going to redraw it right here. I need this height. Now I know that the slant height is 13, which is the hypotenuse, and the base is half of the base of the whole pyramid. So the whole base of the pyramid was 10, so I know this piece is 5 right here. So I have h squared plus 5 squared equals 12 squared, and if you work that out, you should get that h equals 12. That's 13 squared, sorry. H equals 12. Now, once you found all those things, we can just plug them into our formulas. So let's see, we're going to do lateral area first. This is the walls. It's 1/2 PL, which is 1/2 times the perimeter, we found it to be 40, times the slant height, which is 13. 1/2 times 40 times 13 gives us our lateral area of 260 units squared. Total area. It's the 1/2 PL plus the area of the base. We have all those. I already know 1/2 PL is 260. So it's 260 plus area of the base 100. So I get 360 units squared. And volume. Now don't forget on volume, it's 1/3 big B times H. Okay, it's real easy to use 1/2. Well, that's 1/3 of 100 times our height, which was 12. 100 times 12 is 1,200. 1,200 divided by 3 gives you the volume, which is 400 units squared. So it's really not that bad. It's using the same stuff we did yesterday to find certain pieces we need, but use those formulas and find all those variables. Last one says find the lateral total surface area and volume of the square pyramid below. Same basic thing. We need our big P. We need our slant height, we need our actual height, and then we need our area of the base, big B. So they basically gave us 2 of them. They actually gave us the height this time, which is 8. It looks like our square base has sides of 12 and 12. Well, 12 times 4 would give me 48 for my perimeter. And then basically I can find the area too. Length times width, 12 times 12 gives me big B of 144. So this time I have to find the lateral area, but I'm just going to kind of outline this right here. This is my slice. The line right here, that's L. But I know since this is the apothem, it's half of this side, so that's 6. And I think we've all seen 8 squared plus 6 squared plenty of times. I know that equals 100, and the square root of 100 makes L be 10. And now it's right back to what we were doing a second ago. Let's just plug it into our formulas real quick. Lateral area, that's 1/2 PL, so 1/2 of, looks like 48, times our L, which we found to be 10. If you put that out, you get 240 units squared. And you might pause and try to find the other 2 real quick just to practice it. It's not very tough. Of course, you could pause at any time and try these out. Let's see, total surface area. That's lateral. Ooh, did I put 24 up there? Sorry, guys. Let me erase that. Surely you guys didn't miss that up. So 240 units squared, sorry. Total surface area is going to be that 240 plus the area of the base, 144. I got 384 units squared. And then volume, 1/3 big B times H. 144 times 8 divided by 3 should give you 384 units cubed. So guys, it's not that bad. Of course, if you have questions, let me know in class tomorrow. Good luck.